Given an image of a ball. 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 Can you predict where it will go next? Here, 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 here. Where will it go? Question mark. Given an image of a ball, can you predict where it will go next? Given an image of a ball, can you predict where it will go next? Going this way, but then where will it go? Where will it go to next? Yeah. Question mark. Sequence in the world. Audio. Like this. Sequence in the world. Sequence modeling applications. So this ball example, first going like this, going like this, going like this, then going like this. Predict. Can you predict where it will go next? Audio, the sequence in the world. So sequence modeling applications. One-to-one binary classification. Will I pass this class? Student pass. X, Y, one-to-one. One-to-one. Target output, input. Many to one. Many to one. This is direct. This is like this, like this, like this. One to many. Like this, like this, like this. Many to many. Maybe like this, maybe like this, maybe like this, maybe like this. Okay. This is many to one sentiment classification. One to many image captioning. Machine translation, many to many. Machine translation. Machine translation, this Chinese word conversion. One to many, a baseball player throws the ball. Neurons with the recurrence. The perceptron revisited. Input x1, x2, x3. Weight W1, W2, Wm. Z summation. Y equal to G of Z. Output is target output. Feed forward network revisited. Input here x tends to belongs to R power m. Hide node. This is node connection in between x1 to hide node. Y cap for all Rn. This one. Y cap 1, Y cap 2, Y cap 3, and Y cap 4 for all R power n. Here for all Rn. Rn, Rn. Okay. Feed forwarded networks instead. XT, YT at the time. Feed forwarded feed forward networks revisited. XT, this is XT for all RM. RM. Y capture T, Y capture T for all RM. Handling individual time steps. Handling individual time steps. XT, Y cap T. This XT input vector. This YT, Y cap T output vector. Handling individual time steps. Y cap T equal to F of XT. Maybe this or this or this Y of T. So function of XT is coming here. Here function like this coming like this coming. Neurons with recurrence. Neurons with recurrence. Input vector, output vector. Input vector xt, output vector y cap t. Here neurons with recurrence. Y of t, anyone may be y of t. Here y of t, y of 0. Y of t, y of t, y cap t equal to y1. Y cap t equal to y2 cap. Neurons with recurrence. So x naught is connected direct, this way also will go. So h naught this way also go. Hyper 1. I don't know. Sorry, I forget. I will tell you afterwards. So these are output f of each xt. Which one is that time coming? If it is coming, that one is the ht minus 1. Fast memory input. So input we have to calculate. Output is here. Input plus ht minus 1. Past memory. ht minus 1. Past memory, not present memory. Okay. Neurons with the recurrence. Neurons with the recurrence. Neurons with the recurrence. Input vector, output vector, recurrent cell. xt, y cap t, ht, recurrent cell. Neurons with the recurrence. xt, x naught connect to y naught. Y ho, it is connected to y1 also. By h1 it is connected to it is output, its output may be y2 also. Same like x1, x2. So y cap t equal to f of xt at the time of input, comma ht past memory. That is input and the past memory equal to output. Output. Here this one and the past memory also going like this. Recurrent neural network RNNS, recurrent neural network. Recurrent neural network RNNS XT input vector, RNN HT output vector. RNN have a state HT that is updated at each time step as sequence in processor. Apply recurrence relation at every time step. To process sequence HT cell state function with weights W input hold state. Note the same function and the set of parameters are used at every time step. Note the same function and the set of parameters are used every time step. This is function with weights, inputs and hold state. RNN intuition. RNN intuition. X of t input vector, xt input vector, RNN recurrent cell, that is feedback output y cap t. My RNN equal to RNN open close bracket, hidden state 0000, sentence I love recurrent novel. For word in sentence, prediction hidden state equal to my run word hidden state. Next word prediction equal to prediction networks. RNN intuition. RNN intuition. My RNN equal to RNN hidden state 000, sentence equal to I love recurrent neural. For word in sentence, prediction comma hidden underscore state equal to my underscore run of word hidden underscore state. Next word prediction input vector recurrent cell output vector. Here RNN doing prediction hidden state. RNN, this is word hidden state. RNN intuition continue. My underscore RNN equal to RNN open to close bracket hidden state. Sentence I love recurrent neural. For word in sentence prediction hidden state, my run word hidden state. Next word prediction equal to prediction. XT input vector, HT RNN recurrent cell connecting this here. Output vector y cap. Next word prediction hidden state. My RNN word hidden state. RNN state update and output. XT input vector RNN HT output vector. RNN state update and output. RNN state update and output. Output vector. Input vector. RNN. Input vector. What is this? RNN state update and output.